Part winding reduced voltage starters. In this presentation, we're going to be looking at how this reduced voltage starter system functions, as well as what types of motors could be used with its flexible layout. With a part winding reduced voltage starter, it can be used with a 9 or 12 lead dual voltage three-phase motor or a purpose-built 6-lead motor for part winding start applications. The process is very simple. Half of the windings are energized at start. All of the windings are energized for run, which means that there's no reduction in line voltage to the motor at start. This is inherently considered a closed transition reduced voltage starter. If we take a standard 9-lead dual voltage three-phase motor, we know we have 9 individual leads and there is already a start point established in this motor. If we were then to start the process of connecting these in a dual Y or a parallel Y for low voltage connection, we would need to tie 4, 5, and 6 together in a star point. But now what we're going to do is take all 6 leads out to the motor termination box. And when we connect it to the starter will then energize one of the star connected windings at start, and then all of the windings when we transition to run. This is what the standard motor starter looks like. It's quite a basic system with one time delay on energization relay, and we can see that the 2 star point motor windings are actually one motor if we look at a different graphical representation. Let's take a look at how the system functions. We're first going to energize the system, and then we're going to press the start push button. And at this point, 2 relay coils will energize. We have M1 and TR1, TR1 being a time delay on energization relay. The TR1 starts counting down immediately, and M1, the contacts that it controls, will change state. In this case, there's 3 power and 1 control contact that all change state to closed. Once this happens, the power circuit is engaged and the first half of the motor is energized. The motor is now starting. We can release the start push button, and we are now at the mercy of the timer relay to determine how long the motor will run in start formation. Eventually, the timer relay will complete its countdown, and the only contact that it controls is in series with M2. This contact will then close, causing M2 to now energize, which will then control the 3 power contacts for the second half of the three-phase motor. Once they close, we're technically in the transition phase, but notice that the motor is still energized in the previous half, T1, 2, and 3. The power is then brought out to 7, 8, 9, and we have a fully powered three-phase, 9-lead dual voltage motor. This is really no different now in its operation in run as what we would have done for a parallel low voltage connection for this particular type of motor.